Here we're being asked to find the volume of a three-dimensional solid generated by a region revolved around the x-axis. You may want to hit pause and read the question. So here's a picture of this three-dimensional region, and it's worth noting here that while x and y are the variables in this problem, R and H, while they are letters of the alphabet and unknown to us, they actually represent specific constants. And so what we're really doing here is not working out one particular volume. We're working out infinitely many problems at once where R and H could be any numbers whatsoever. So for example, if after I'm done with this problem, I wanted to know what the volume would be when we were looking at, say, y equals 2/3 x, and that region being revolved, then I could use an R value of 2 and an H value of 3. And so we're really solving a whole class of problems here. Bottom line, R and H are numbers that we don't particularly know or care about at this point. So what we'll do here is we'll use the volume formula for a region revolved around the x-axis. We'll plug in our particular function here, and we'll do some math. Now, one thing that's worth noting here in this next step is that we've factored out the r squared h over h squared outside of the interval. Normally, you can't just bring something from the inside of an integral to the outside. But when it's a multiplicative constant, and we are thinking of r squared over h squared as some constant, then that's a perfectly legal move to do. Continuing integrating and doing all of the algebra necessary, we ultimately get the volume of this three-dimensional solid. And what that means is, sorry I had to hit pause, kind of lost my train of thought there, had some family members in the room. Don't remember what I was saying, but what's worth pointing out here is that we have actually just proved the volume formula for a cone. And if you want to ponder that for a moment, I'll let you do that. Thank you.